So the first section on quadratics dealt with mostly vertex form and graphing. I had this conversation yesterday with Rex. What we get into next is when we did linear equations. If we had two linear equations, we wanted to find the intersection point of two lines. We learned three methods to do in order to do that. The first method we learned was to graph it and find out where the intersection point is. The second method we did was adding and subtracting, and the third method we did was substitution. We're going to end up doing the same thing here, okay? But we're also going to end up finding roots and intercepts, which you've already done. So it's not going to be too much new information in that sense. Graphical solutions of quadratic equations. So basically speaking, what we are now looking at, the last section, our primary focus was on the vertex. So our primary focus in chapter 4 is on roots. Okay, find your zeros, find your roots. So the first way to do it is to actually graph it using technology. So you can use Desmos, you can graph it, you can find your roots that way. Pretty straightforward. You shouldn't have to, as far as I know, you shouldn't have to do any completing the square. You should be able to just use the graphing parts of this and then factoring to solve for the roots of the equation. Okay? Determine the roots of each equation by graphing the corresponding function. Use either paper and pencil or technology. You can use technology for this. X squared plus 6x add 3. Who does not have Desmos? Everybody has Desmos? Yes? Okay. I'm going to actually skip this. I'm going to move just to page 150 for right now. So what you noticed on the last test, you had pretty much everything was primarily the same and then one problem, which was a doozy. Okay? Not a lot of us got it right, but this question, like if you look at your notes in your book, like in your textbook, in your workbook, that's what they do. They give you 1, 2, 3, and then they give you a fourth question, which is always a problem. So we still have to focus on that a little bit. The profit P of a particular company makes from selling its product is modeled by the following function. P of n equals negative 0.1 n squared plus 100n minus 21,000, where n is the number of products sold each month. Graph the business's profit function. Explain why it is reasonable to model this situation with a quadratic equation. Okay, so first thing I want you to do is take out your calculators and graph this for me, please. Because I don't know what the vertex is. So the equation is this. Grab your phones. Put them in test mode. Okay, you can graph that. Just for the heck of it, I'm going to factor this and complete the square because I want to know what the vertex is. You can get it by graphing. Oh, this is 500 squared, that's why. Okay, so let's try that again. Okay, calculator. Okay, is that what you get as your vertex?
No. 504,000.
5,000 squared. Oh no, it should be 500 squared. No.
The B is 500.
Oh, 500. That's right. Five hundred.
I think that's what we're going to get 500.
Yeah,
500.
Yeah, you're wrong.
Yeah.
Right now?
No, 500.
500 and 4,000.
500. Oh, 500 here. Okay. So 504,000. Okay. Finally got her. Right in. How many of us got that on their calculator? Okay. Now, so it says graph the business profit as the function. What does the $4,000, what does it represent? Maximum profit. And what do they have to sell in order to get that maximum profit? 500. Okay? Now, the next question is, what's the break-even price? Or not necessarily the break-even, I know what break-even price is, but what is the value, how many do they have to sell in order to get even? $0.
700.
What do you think it is?
700.
700? Why?
Because that's the second root.
Because that's what, sorry?
That's the root.
The root. Okay? Well, where does it break even? Take a look at your graph. What is a break-even point? Right there and right there. So they have to sell 700 or they have to sell 300. So if they sell 700, they have to put out too much in order to get to 700. You understand what I'm saying? So their costs at this point, okay, is the same amount as what they're going to take in revenue-wise. All right? So the profit, the maximum profit then here was 504,000 is what they would make. All right? So it says, graph the business profit function, explain why it is reasonable to model this situation with a quadratic equation. Well, it's reasonable to model it because somewhere between 300 and 700, because those are your break-even points, you're going to continue to make money. But there's got to be a point that they hit a maximum amount, sell a maximum amount to make that maximum amount, and that's our vertex right there. So we can do that with a quadratic equation. A business hits a break-even point when its profits are $0. At this point, the business neither makes or loses money. So determine how many sales that is. So 300 sales or 700 sales. Okay, pretty straightforward. Again, you have your calculator to do this. Okay, that's method number one for finding your roots. If you recall from applied, we had multiple methods of finding roots. The first one was graphing. What was the second one? How do we find roots? What's the process? No. How do we find the zeros of the function? If I give you an equation, how do you find the zeros? Factoring. There's the second. All right. What else do we have? What if it couldn't be factored? How did you find the roots without graphing? Quadratic equation. There's your third. And then your fourth is what we just did, which is completing the square. That'll be a new method for you. So the second part of this is, can you factor quadratic equations? So let's look at page 157. Let's just review factoring for a second, even though we've just done it. What's the very first thing that you always do when it comes to factoring? Greatest common factor. That's the very first thing you do. Okay? Second is, what happens if I have a binomial and there is no greatest common factor? How do I factor that? What's this called? Most factorable. Anybody remember what this is called? How do I factor that?
Substitute in.
No.
To make two of them. Like bracket A, B, other bracket A, B, and then like that.
A plus B.
Yeah, A plus B, but twice.
What's that called? You remember? It's another word for subtract.
Difference of squares.
Difference of squares. Good. Perfect square, subtract a perfect square. Good thing we brought the grade 10 along for the ride, eh? Same thing you guys did. You
It's
remember?
pressure in his mind though.
Oh, you did it last semester as well. Is that a perfect square?
Yeah.
Is that a subtract sign?
Yeah.
Is that a perfect square?
Yeah.
Yes. So, square root of this, x over 4 minus 5y, x over 4 add 5y. Okay? You have to identify when it's a perfect square, subtract a perfect square. You are going to see this loads of times as you go through grade 11 and grade 12. Alright? Example B. 9 x minus 1 squared. Subtract 100y squared. Is this difference of squares?
Yeah.
Yeah. Okay, what's the square root of this guy? Square root of 9.
3.
3. Square root of x minus 1 squared.
X minus 1.
X minus 1. Subtract square root.
10.
Y.
Y.
So that's a minus b, a plus b. And then you should multiply through and get rid of the inside brackets. Leave the outside brackets, but get rid of the inside ones. So I'm going to have 3x minus 10y subtract 3. 3x plus 10y subtract 3. And that should be your final answer right there. Okay? I'll do one more with you, and then we'll let you work. You still writing that, Shay?
I'm in.
You good?
Yeah.
Good. How about this guy? Hi.
Missing Jalen, right?
She hasn't been around all week, except for Monday.
Okay, thank you.
Yeah. Plus. All right. Okay, can we factor this? Can you factor that?
Well, x plus 3 is the greatest monkey count.
Yeah, it's a good idea though, Rex.
Could you cube root it? That's better.
No. Okay. What if I rewrote it like this? Think we can figure out how to factor that?
Yeah.
Yeah? Well, what's the difference? The only difference is I made a and x plus 3 the same thing. Okay? Now, you should write this down in your book because most of you obviously have forgotten all about factoring. I have, if I can't take out a greatest common factor and I have an a value, first thing you do is product of a times c. So in this case, that's negative 40. Oh, negative 20, sorry. That was 10, negative 20. All right, now I need a sum, which is my b value, of plus 8 from my factors. What are the factors of negative 20 that add to give me 8?
10 and negative 2.
Good. 10 and negative 2.
You can rewrite it into brackets.
Again, write this down. You have to do this. So now I'm going to substitute that in. 4a squared minus 2a plus 10a subtract 5. So I put these two guys in my middle. Instead of 8, I put it in here. Now what I'm going to do is I'm going to two sets of brackets like that. And then what do I do from here?
Factor out.
Factor out. What can I take out of 4a squared minus 2a? 2a. It's going to leave me with 2a subtract 1 plus. What can I take out of there? 5. 5. It's going to leave me 2a subtract 1. Now in order for this to be working properly, what do I need to remember?
2a subtract 1 and then 2a plus 5.
My two brackets, that's right. My two brackets have to be the same. If they are not the same, then I haven't done it correctly and I have to try again. So they are done the same. Now I factor out what's common, 2a minus 1, and what am I left with? 2a plus 5. So now what do I have to do? Instead of a, I'm going to substitute in x plus 3. There, and then get rid of the inside brackets again. Subtract 1 is 5. Oops.
No.
No, I didn't do that right.
4.
Okay. Oh no, I was right.
Subtract
2x
1.
plus 6. 6 subtract 1 is 5. 2x plus 6. 6 and 5 make 11. There's your final solution.
Can you go okay, so come on, so
Can you explain how come we know it's factor is 10, right?
What do I multiply to get to 20?
On
Yeah, or 10 times negative 2. Because it has to give me something that adds to 8. It has to be the factors of negative 20 that add to give me 8. Okay? So, if I look at negative 20, right, all my factors are, start like this. 1, negative 20, negative 1, 20, right? 2, negative 10, negative 2, 10, 4, negative 5, negative 4, and 5. Those all give me negative 20 when I multiply, right? But which one of these adds to give me 8? So the one that adds to give me 8 is that guy.
Right.
So then that's why I use it. I substitute it into the middle here. Instead of 8, I put 10 and -2. Okay? All right. You have the remainder today to finish off 4.1, and it's, like I said, use Desmos and graph all of this. That's all you need to do in that. If you get done that, you can go on to the second part, but I don't think you will. There's some problems in there. Okay? Test or mark, I just have to total them and then I'll put them on online.
Yeah, are you going over that problem from the test? I guess once everybody's done the test.